Hey guys, welcome back to Project Syncro. This week, we're going to be talking about my NASA-inspired switch panel. We'll talk about how I designed this panel, some of the considerations and difficulties I had with cutting it out on the laser cutter, how I went about assembling the panel, getting the panel all backlit, and some of the things I'm going to be doing just to finish this panel out, get it all in a nice, cozy enclosure, and finally, how I'm going to install it in the car. So stay tuned. Thanks. Okay guys, so this process really started with one simple prototype. This little piece of cardboard I have here with a little piece of the space shuttle or the orbiter flight deck panel on it. I knew for a long time, a really long time, that I wanted to put a NASA-inspired switch panel in the rally car. I wasn't sure if that was going to be something on the dash itself, or if it was going to be in its own box, kind of like I have it now, or how that was going to shake out. But even before I started putting the cage in the car, I was already sourcing these NASA switch guards. If you guys listen to the podcast, I've got a lot more detail on the switch guards themselves. I won't go into that now, but suffice it to say, this is pretty close to NASA specs, so somewhat within reason. I want to keep costs a little bit under control, but I wanted it to have the look and feel of 80s era NASA hardware. So this process really started with finding a good scan of the orbiter flight deck control panels. So I sort of flipped through all the pages of control panels and hearkened back to my days of space camp and remembered that I was the pilot, and the pilot sits in the right seat of the orbiter, and one of the most important jobs that the pilot does is control a lot of the power systems. Not just on orbit, but during launch, they need to know how to do, I believe it is the APU pre-start and APU start procedures in just seconds. They have a very short window to do it. They read through the procedure, but I mean, any good pilot, like myself at space camp, had to have that process memorized and flip through all these switches. So naturally, it just happened that the forward part of, I believe it's panel R1 or panel R2 for APU starts had a very similar layout and switch count to what I wanted to put in the car. It was pretty clear way back when I started the cage. I mounted the seats before I built the cage and realized that when I'm belted in, as is common in a lot of rally cars, there's no way for me to reach forward and reach the dash to really change any switches. My driving position is so far back and so far reclined. You'll see this in a lot of cars, even professional WRC cars. You want to get centered right in the B-pillar, just for safety, center of gravity, a whole lot of considerations, but that puts you at a disadvantage for controls. So what I decided on was to put that switch panel in between the two seats. So really what I did when I printed out this section of control panel is I wanted to get a rough feel of a size and see how much real estate I had in the car, how many switches I could get away with putting in there. Could I even read this thing? So what I did is I printed out, put it on cardboard, and I actually put switches in here, thread them all together. You can see the photos on our page, and set it in the car, set myself in the car, put my helmet and Hans on, and really made sure that that was going to be reasonable for me to reach down, maybe look over, sort of faked it like I was belted in, and make sure that this was a reasonable thing to start spending a whole lot of time on, is putting a panel here. So thankfully, beyond a doubt, it was totally legitimate to mount a panel in between the two seats. I'm going to be getting belts that are center pull straps, so you won't have to worry about flopping a belt over and crashing into this panel or anything. And it's a fairly safe space to have a panel. It's also really good to have both of these controls accessible, or all these controls accessible by the driver and the co-driver. So when I have something mounted in there, if it just so happens, as much as I want to avoid doing adjustments or changing anything while I'm on stage, while I'm competing, that might need to happen. And if for some reason I can't do that, the co-driver can do that as well. And you just have the option. I'm not saying that's always going to happen, but it's nice to have that option. So once I was certain that's how I wanted to fab this panel up, and that's about how much room I wanted to work with, I picked a size, and I picked 5 inches wide by 11 inches high. And I started sizing everything around that. So the first thing I did was I jumped into a really simple, I did all of this work in CorelDRAW. I started to try and do this work in AutoCAD, and my AutoCAD skills are just not up to snuff, and I didn't really like the way that AutoCAD handled a lot of the designs that were not solely based on strict dimensions. There was a lot of, I wouldn't say guessing, but there was a lot of sort of, well, it is guessing, really. There was a lot of guessing that went into getting text placement where it needed to be, and there was a lot of fiddling around with text sizes and stuff that just didn't seem to work right in AutoCAD. So I decided to go over to CorelDRAW, which was a really well-known editor, a drawing program or a vector graphics program that actually shipped with my cheesy 3D cutter and engraver, and it actually worked out really well. I expected it to be hokey, because when you think of CorelDRAW, you think of like some old woman that still uses AOL and is like making Christmas cards or something like that. That's what I thought of, but it's actually a really pretty good program. So I started off by just making a layout roughly based on this test panel that I used. I dimensionally sized all my switch guards. I put that all in there, and I grouped everything properly so I could really quickly just move switch guards around and get stuff organized. I built in a bunch of guidelines, a whole guideline layer, just to make sure that everything was fit and snapped properly so I could make changes on the fly and what have you. And I started hashing it out, and you can see the first thing I did was really to just get the switch layout, and then I printed like 5 of these sheets that didn't have any text on them at all, and I just started writing. I hand wrote, I erased, I hand wrote again, I looked at it, I said that doesn't look right, maybe I'll put a line here, and I was able to work really quickly on a sheet of paper and not be frustrated with looking at something on a screen. I could actually, draw something how I wanted it, kind of throw it on the chair, throw it on the floor, and see what it looked like in front of me before I spent all the time getting it in the computer. So once I was able to get everything into the computer, once again, I printed it out, and I actually printed it out at work because the design changed shape slightly. I realized that I needed another row of switches, so it grew from 5 inches wide by 11 inches high, which will fit on an 8.5 by 11 sheet of paper. It grew to 12 inches. So I printed out an 11 by 17. I cut out a 5 by 12 inch piece of cardboard on the laser cutter, and I laid it on there. Then the next step, I don't have it here because obviously they're on the panel, is I took my switch guards, took double-sided tape, and I stuck them onto the places on the test sheet, and then I set that in the car. And what I wanted to make sure was that I would be able to read all these little labels that I had scrunched up so closely to the switch guards, and make sure that I could read all the stuff in between all those guards. So it actually worked out really well, because if you think of the placement in the car and you think of where I'm looking, I'm almost directly, the co-driver as well, are almost directly over the top of this. So you don't have to worry about looking at it at a strange angle or any kind of weird tilt going on. There was a little bit of that because I wanted to make sure I could reach properly and within reason. So once I confirmed that my spacing was correct and not too close or not too far away from everything, then I really started testing with the engraver. I'm fortunate enough, and thank you to Paul and Matt at Diode Dynamics, they gave me a lot of scrap, what I just call Romark, but what it is a company called Romark makes a product called laser etch or something like that. I should really know this because I had to buy some of it. They make this product that is a colored opaque acrylic with another color Mylar coating film over the top of it. So you can engrave through this Mylar coating and reveal the colored acrylic behind it, put a light behind it, and you won't see light where the Mylar coating remains, but you will see it where the text remains. And that's really the name of the game here for getting this thing backlit. If I didn't want to backlight this, I would have just printed a sheet of paper out and laminated it or something. You know, I would not have put this much time into it had I not wanted to get that true, authentic NASA backlight. So once I had this design, like I said, I jumped over to the laser cutter, and Paul and Matt gave me a bunch of their scrap Romark, and I was able to dial in the laser cutter and the settings and use all this stuff to eventually work my way over to a full up cut and engrave of the panel itself. And I was really excited with this. Again, check the Facebook page if you guys want to see all the pictures of my progress. Unfortunately, we don't have any video, but I can honestly tell you weren't missing much. It was just a lot of me cursing and fighting with it for hours on end and staying up really late trying to get this stuff cut properly. So I stayed up really late one night, got this cut out, got it all put together and fabbed up and everything, and was super excited, and went to bed, got up the next morning. I said, all right, today's the day. We're going to cut out the real deal. We're going to do it in gray, and we're going to get this all done. So in my haste, I cut out a piece of the gray Romark, threw it in the cutter, and if you remember from the last video, I mentioned that I have to do the engraving first, then switch the file over to a cut file, and then cut around this. Just by nature of how the engraving happens, I had to do it as a JPEG file, and there was a border. I had to place a border around the JPEG file to make sure that it was, you know, it was going to stay dimensionally accurate, it was going to be placed properly. And one of the side effects of that is I knew that my cut line should be right on top of where that border got etched. Well, the first one I did, it got bumped slightly. It turned out that the hose that I used for the air shroud on the tip of the laser cutter bumped the panel, and it moved it. I said, oh, how could I have made a mistake like that? So the next one I thought, oh man, this is, you know, this is really tough love learning like this. So I put some double-sided tape on the bottom of it, and I stuck the next piece of gray down, fired the machine up, and it finished, and it was off again. I thought, that's strange that it's off again, but it's off only in the Y direction. It's off only in height, because if you think about it, it's in the machine like this, and it was off in the Y direction. I thought, why is it off in the Y direction? And I went through sheet and sheet of cardboard trying to figure out what was going on, and wasted a whole day doing this. And if we take a little break here, we'll go over to the laser cutter, and I'll show you just exactly what went wrong, what I missed, and all the changes I had to make to get this panel to finally cut out properly. Stay tuned. So my first thought was that I had made a mistake somewhere in software when I was exporting all these different layers into different files and steps to be ran separately, which was my earlier complaint about the software, is I can't do everything all in one file. Like I mentioned, in some better editors or cutters, you can define different colors to be different cut or engrave powers, and make sure you have everything in one file. I couldn't do that in this case, so it was this elaborate situation where I would switch on and off layers in Corel Draw and export the items that were still visible, which is really powerful and makes it easy to edit, but it was also kind of a pain, and it may, I thought, induce a little bit of error if when I imported those files into that cheesy Moshi Draw cutting software, that maybe something got bumped, or I accidentally saved over a file and moved something around. And I could have swore that the only way that this would be lined up exactly in the x-axis, but only off in the y-axis, is by software. Because when you have, if you had random error or problems with the hardware, you would think it would just be off in whatever direction it's off. It wouldn't be so repeatable. So I cut another 2 or so sections on sheets of cardboard, and I realized that the gap between the etch layer and the cut layer was changing. I thought, well, how could this be? Now it's random. Okay, so if it's random, it's not software, because you know, a computer does what you tell it the same way every time. It would be foolish of you to do, you know, ask it to do the same thing and expect a different result. That's like, isn't that the definition of insanity, is doing the same thing and expecting a different result. So I started measuring that, and I thought, I'm not quite sure what's going on, but I'm fairly certain it's a problem with this hardware. Big surprise, it's a, you know, cheesy piece of Chinese laser that I expect to just be so dimensionally accurate. And I slept on it. And then I woke up. Actually, I couldn't sleep. And it dawned on me that when I took this whole system apart, put it all back together, the thing I didn't really mess with was the XY gantry itself. And what I definitely didn't check were the belts, the drive belts. And it turned out, as soon as I came back down here, I got back out of bed, I didn't put any shoes on, and I came down here and I reached around and realized that the belts were loose, but they were only loose in the y-axis. They weren't loose in the x-axis. So the X motor was moving the head back and forth properly, and it was always in the same place, you know, because you didn't have any slack. But the y-axis would engrave from the top down, but it would cut from the bottom up. So that means you apply torque on a belt, and it's going to be taut on one side, and then when you roll off the back side of the pulley, it's going to be loose on the other side. So that amount of looseness was the amount of error that I had, because when I was engraving, I would kind of pull the head one way and tighten the belt that way, and when I would cut, I would pull it the other way and tighten it that way. So that slop was my error. So overnight, I pulled the head out, or I pulled the whole gantry piece out. I cleaned and lubricated all the bearings, and I tensioned all the belts properly, and installed everything back in, lined up the laser. That took forever because you actually have to true the base, make sure everything is true, and it took me forever to line the laser back up. But finally, whenever I got all those steps done, it started cutting perfectly. My engraving, the text on the engraving was far more detailed. Maybe if we can get a macro shot, you can see the level of detail on the engrave layer. All of my holes, when I cut, all of the holes, instead of being pretty much exactly round, they were exactly round. The first problem I had with that test piece that I did is when I cut a hole, it looked perfect, but when I went to put a bolt through it, it didn't quite fit. And I just thought, maybe it's just, my dimension was a little bit off or something like that. I thought I had measured it, and I didn't get it right. So when I cut it out the second time, bolts fit right in. Everything is exactly how it should be. So once I did all that work to get the machine dialed in once again, I cut the final panel out, and thankfully it was dead on accurate. It fit the rest of my hardware perfectly. It lined up to everything else perfectly, and I was finally able to put this thing together. So we're going to go back over to the workbench now, and I'll show you how I got to where I am now, and how I'm going to be moving forward from here. Okay, so once I got the panel cut out, as I had mentioned before, I had multiple layers in this Corel Draw file that I was using to actually put this thing together. And one of the layers behind the main cut and engrave layer is a layer that is just the holes for mounting the switches. Here's the prototype I made. I just had some acrylic handy, and I wanted to cut out a sheet, a really stout sheet to mount everything in. Obviously the engraver couldn't cut metal, but I really wanted to get something stamped out quickly so that I could put this thing together and make sure it looked all right and felt all right in the car. And again, just another confirmation that I could continue to move forward on this without making any crazy changes. So this is the switch, and I believe I just called it the hole layer because this is the mounting holes for all the switches, and then the M6 holes for all the hardware that mounts the layers of the panel together. So the switches and the switch guards themselves actually mount to this panel, and then if makes it really neat that if I want to remove the backlit layer or remove the panel layer or swap it out or clean something or whatnot, those are just layers that are sandwiched on top of this. So it's not like I have to actually put this thing all together at once. If you take a look here, these are actually separate pieces that are not bolted down by the switch guards. And again, that's, if you look really closely at the orbiter flight deck Gigapan image that I think I had shared in the past, if you zoom really closely in, and I have a picture of this on the page as well, you can see that there's a little recessed section where the switch guards are mounted, and the panel sits proud of that. And that's something that we need to do as well, just because of how high the edges of these switch guards come up. It looks really odd or it would have looked really odd if I had just, engraved a panel and just slapped these on there. Obviously, having something other than the acrylic panel itself is important because you want this thing to remain rigid. So I chose to use a sheet of aluminum, and as you guys may have seen, obviously this laser cutter can't cut aluminum, but what it can do, again, is etch softer materials. So I laid out a bunch of painter's tape on the sheet of aluminum, and I had yet another layer in this Corel draw file. That it wasn't the holes, but it was the hole centers. And I marked out all these hole centers and used that and etched them on the tape, and was able to line up a center punch and then fire up the old drill press and drill these holes out to size and clean them all up. And they were perfect because I engraved them directly out of the file. So I didn't have to worry about laying out all these holes and whatnot. I just made the laser cutter do all the work for me, which was awesome, and I was able to really quickly stamp out this panel. So that got me the panel, and it looked great. But once again, I wanted to move on to the backlit section. So as I had mentioned before, I had this electroluminescent panel, and here's just a little sample since the actual piece is in there. And it's these two layers that are coated. I'm going to make a fool of myself, so maybe if we need to explain it in the future, we will. But there are coatings in there, and you apply a voltage across them, and they energize and they emit light. You have to use a little inverter to actually invert from DC over to AC and run AC current through this to light this thing up. And it's totally flexible. It's also cuttable, which is just awesome. And it's somewhat dimmable, although I don't really plan on dimming it because I think it's right at the right brightness. But it's exactly what you want for illumination behind a panel. It's what NASA's been using back to the Gemini, I believe. Maybe they didn't use it in Gemini, but they definitely used it in the Apollo era to backlight all their panels. So, got a sheet of that from China. It had this really hokey, and if I can find it here, it had this really hokey set of leads. And these leads, if this, say this were the edge of the panel, these leads just sort of hung off the end of it. And they were really brittle, and I think I was able to just break this off by hand. I said, well, that's not going to be a good plan. So what I ended up doing was the leads ran all the way up the side of this panel, and I just went up to a reasonable area where I knew I wouldn't have switches mounted, and I just very delicately scratched off this coating and revealed the strips of copper that were underneath. I tinned those, and I just cut my wire up and moved it up to inside the panel itself. Now, obviously, I didn't take this into consideration the first time I cut the panel, so unfortunately, I had to disassemble everything again, make a little notch for the wires to sit below the panel so that everything could be nice and flush. So, again, once I got that done, I tested it. I knew that it worked, so I used some of this 3M Kapton tape, another, I believe, sort of Apollo era creation, this is the tape that if you've ever taken like a laptop apart or something, it's what's holding a lot of these ribbon cables and stuff down. It insulates, it's very heat resistant. It was used to hold a lot of this stuff down to the lunar module, which is really cool. The only manned spacecraft that was not designed to re-enter the Earth's atmosphere, which is like super cool. I guess you could call the space station that as well. But if you know all that gold foil and stuff on the side of the lunar module, the descent stage of the lunar module, all of that foil is just taped on with this Kapton tape, which is ridiculous. So this is a standard whenever you're building wiring harnesses and things. You just use Kapton tape to hold everything together, and it's awesome. And it's really not expensive. Somebody asked me, I said I got some Kapton tape, and they said, man, how much did you pay for that? It was like $5 for a roll. Everybody thinks that it's sort of gold foily looking, so it must be really expensive. But no, it was on Amazon Prime for like $5. So once I got the electroluminescent panel working, I laid it on, or overlaid it, and I traced around all of the sections where I would need to remove center sections of panel, because not only did I not want to bolt the switch guards through, I wanted to be able to seal in between and actually seal off the EL panel from the elements, because if you think you cut this edge, you're going to have an exposed edge that you get moisture and crud in and really cause issues. And I know this thing's not going to be 100% waterproof, but it better at least be water resistant if I want to wipe the thing off or accidentally get a little bit of fluid. You know, the car's going to get really filthy. Hopefully it doesn't get flooded or soaking wet or anything, knock on wood. I don't want that to happen, but the panel's going to get water on it, and I better plan for it. That's why I got those switches, and that's why I've done all this work. So what I plan on doing is I trimmed back that EL panel, and I'm going to run a little bead of gray, what I call Honda Bond, but it's kind of like a nicer RTV that's very common, and seal off the edge of that EL panel and make everything look nice. I also want to paint the aluminum and whatnot. And there's some finishing details, not including the box, which we'll get to, that will finish out the surface of this panel. But as far as the EL goes, it needs to be trimmed and it shouldn't be proud of the gray panel just to keep it safe. So what we're going to do now is plug this thing into the inverter and fire it up, and we'll get some footage. I know I posted a little bit of smartphone footage, but you really couldn't get a feel for how awesome this thing looks backlit, or quite how well or not so well lit certain aspects were. So we're going to hook this thing up, we'll turn the lights off, and we'll get a little bit of video. Okay, so now that we have the backlight working, and hopefully you guys are doing the same thing I did, is just rewinding, and I would look at it in the dark, and I would take photos of it, and then I would look at the photos, and then I would make a video of it. I was just enamored. I was over the moon in a somewhat pun, kind of an ironic way. I was totally over the moon that I had made something that, even in this infantile state, looked close to what would be in a spacecraft. I had a friend of mine, Paul Cruz, who does endurance racing. We've been talking back and forth on car setups for a while, and he said, "You are absolutely the nerdiest racer that I know. Most racers are fairly nerdy, but you're just over the top," which, obviously I would take as a compliment. I know a lot of you are in the camp of just get the car finished, get it reliable and do all that stuff, but just get it finished and get out on the stage. I've had so many people that have been rallying for years, yelling at me because it's taken me this long to finish the car. And a couple months ago, I figured out it really doesn't matter. I'm working on it. I'm working on it almost every day. I'm thinking about it every day, almost every hour of every day, which sounds bad, but I do even at work, and it keeps me from sleeping. So no one can fault me for not doing any work on the car. You can fault me all you want for not getting it done in a timely manner, but at least I'm doing really cool stuff and enjoying it. So I had to step back for a minute and finally just admire that something I made looked how I had always dreamt that it would look. And I know that I'm going to finish this thing out, and it's going to look even closer to how I want it to look. And I don't know, I'm just super excited about that. So just to round this out, some of the final things I need to do. So I'm actually going to use some of this 1/4 inch acrylic. This is more of a Lexan. It's not glass fiber reinforced or anything crazy, but it is really, really impact resistant and really really strong stuff. So rather than trying to piddle my way through like TIG welding an enclosure up or doing something super cheesy, I thought, well, again, I might as well put the laser cutter to use, and I am just going to cut walls out, cut borders out, cut a bottom out, and glue myself up a box. So what I have to do that with is, it's called, a company called Weldon makes this, or maybe they're a different group now, but everybody knows them as Weldon. This is Weldon number 3, which is a very fast setting, clear acrylic. It's more of a welding agent than it is a glue. It's not really fair to call this stuff a glue because it actually just melts the 2 layers, and in the purest sense of how a weld occurs, it's bonding those 2 materials together for a joint that is as strong, if not stronger, eventually than the material itself. So this is what you use to make, crazy acrylic aquariums and stuff like that. It's definitely, if you do everything right, it can be waterproof. It can be super strong and impact resistant in pretty much every dimension. And since I cut it on the laser cutter, I know it's correct, and I can get it done really quickly. So just to give you an idea of how crazy this stuff is, I had to really, really put the manly strength and get a rubber glove over the top of this to get it open. And once you open it up, if you look at this, it's still sealed. It's crimped closed, and there's no pull tab to even open it. You have to cut a hole in it to be sure that you actually want to get this stuff open, which is nuts. So I got some of this. Weldon number 3. And a couple of little, they call them hypo bottles, but what they really are like 24 gauge hypodermic needles and a little dropper bottle. And you draw some out with it, and you put the 2 pieces of acrylic together, and you run, just as you were welding, you run a bead down that joint, and it diffuses in there, and within 1 minute, you have 1 minute to work, and then the item is fixed in 2 minutes, and it's at 80% strength overnight. So this is crazy stuff, and this is like the industry standard for joining pieces of acrylic. So that's how I'll make my box. I've got, I haven't 100% decided the plug that I want to put in the front of this. I have a Russian military surplus twist connect weatherproof plug that I might use. I might use a standard DB plug. I might find a series of weather pack connectors, or a SMJ, I believe, a firewall junction or something to use, because think of all the wires I need for all these switches, that it's going to take a big plug or a series of plugs to hook it up, and I want to make sure I can keep this box nice and watertight. So the other piece that I have to do is actually mount this to something, and what I'm planning on doing is cutting out little holes in here and putting in riv nuts, which are like rivet nuts. And I bought a riv nut kit a couple of months ago, and I used it, I believe, I just used it to mount something in the car, and I can't remember what. Maybe it was related to the shifter or something. But they're brilliant. Oh, I used it in the Zero Car GTI to make an ECU mount, and it's really just the standard way that you would run a pop rivet in, but instead of that center pin being through there, it's a threaded section. So you use it, you apply it like a rivet, and it pulls itself up, and it's splined so that it won't spin. And once you pull the fixture out of it, it's a nut. So I'll have a little metal nut embedded in the enclosure. So I'll be able to make little U-shaped brackets and mount this thing down to the firewall. And I'll show you what we're working with that, but I'll be able to get that angle fine-tuned and whatnot, and hopefully be able to get this thing done in the next week or so. And probably won't do another whole episode on just the panel. I really wanted you guys to understand the process I went through to get this thing ironed out and just to the point where it is now. We might do a few more shots in the future, in a future episode when I have it finished, maybe a little short snippet of the complete final project, or maybe we'll just do an album. But anyway, I hope you guys enjoyed seeing all the work that I put in this thing so far. And again, thank you guys. I've seen a lot of really, really cool comments on the photos I posted. I know I've tried to not be as crazy overzealous excited on the Facebook page as I really am about this thing. And there are times when I don't want to brag too much, and I want to share all these crazy photos, but I try to keep it somewhat tame. But you guys have posted really awesome comments, and I'm just so excited that everyone else loves this thing as much as I do. So thanks again. Again, be sure to, I've seen a couple people sharing stuff, which is awesome. I love that. Please continue to share stuff. I love seeing, I think somebody shared it on another like art page, which it didn't even dawn on me that something I did could be considered art, which is super cool. So I love seeing stuff get shared. Again, be sure to like and subscribe both on facebook.com/Project Syncro and youtube.com/Project Syncro. And Kyle and I appreciate all the views, all the comments, all the likes, and everything. So we'll see you guys next time. Thanks again. If you want to sync.